Last bit here. So we're in section 1.4. We're going to finish this up. Increasing and decreasing intervals is exactly what it means. Basically, can you give a graph and tell where the graph is increasing, where it's decreasing? So if we start with example 1, let's just say we have something like this. All right, here's the picture here. So let's just say you get this here. Okay. All right. So obviously, increasing, if we say the graph is increasing on an interval, we mean it's doing what? What is the graph doing? How could you describe it?
It's positive.
Yeah, so if you were thinking of slope, it'd be positive, like a line. You can just say going up from left to right. So, you know, it's going up. This is the layman terms definition, by the way, but going up from left to right. But it is from left to right that we're looking at this. Now, so we want to describe it similarly to how we would describe domain. So like we give increasing and decreasing intervals like over a range of x's. Well, I should say range of x's, but over a span of x's, okay? So we got some information that's missing. These important points here, which I don't think you'll have to find them, but if you, because it's going to give you the picture, those points are important because those are turning points where the graph changes from one to the other. This is called a maximum. It's actually called a relative maximum. I'm just going to call it a max. So that point, you need to at least know this location. So let's say this maximum is at 5, 7. Okay, that's where it is. So it's at 5 on the x and 7 on the y. And let's say this minimum here, so this is a minimum. Let's say this is at -1, -2. Okay, there's that. Okay. So you need those locations. If they just give you the picture, you should be able to kind of eyeball it on the graph there. All right. So now what you're going to do is, well, let's define decreasing real quick since we did increasing. What's decreasing?
It's the opposite.
Yeah, just say going down from left to right, right? So we'd say going down from left to right. The technical terminology would be, I mean, it sounds awful, but it's like as the x values are increasing, you could say the y values are decreasing, something like that. Okay. All right, there is one more interval we should discuss would be a constant interval, like a horizontal segment. So we do have constant intervals, and on those, if we say the graph is constant, then we're saying it's just no change in y's. So you have certain graphs that they could have these horizontal segments like this, okay? So it could be possible. All right. So on this example that I've given you, it's going to say give the increasing interval in interval notation, give the decreasing interval or intervals. So if you want increasing, we're going to use interval notation. Here's what you do. You use x's. Use x values to tell where graph is increasing. Okay? All right, and the same for decreasing. You use x values. So for decreasing, use the x values. Same idea. All right, so I will work this similarly to like if I'm doing domain. So as I look at this picture, we can see where it's going up. Our main focus are the x's. I use the x's to tell where give the interval. So I say from this x to this x. Now, remember this way out here is what? What's way out here? What x? Infinity, and this is negative infinity. Okay. So let me ask you this, first of all, how many separate intervals do you see in terms of going up or going down? How many separate? You should see three, all right? Which one is the increasing one? If you look at the left, the middle, and the right, it's increasing where?
Middle,
Middle. What are the x's that it's increasing from where to where?
-1 to 5.
-1 to 5. Now, you just put parentheses. I know we said brackets includes, but you gotta think, at -1, it's a changeover. So it changes from decreasing to increasing. So we don't really include it in one or the other. We use a parenthesis. And then that's the answer for that. That's where it's increasing. So you see if you can do decreasing, and remember, if you do more than one interval, you'll do like a union symbol. So I'll give you a hint. On decreasing, it's gonna go like this, and then it's gonna go like this. That union symbol means this interval or this interval, it's decreasing, okay? So see if you can give the two intervals there, and you work it similarly. Again, we use the x values. And once you get done with example 1, move on to example 2, do increasing and decreasing intervals. So let's see. All right, let's think about our answer. All right, so if we look at the first interval, we always give it left to right in terms of the x's. So we would say, from where to where is it decreasing?
-infinity to -1.
Yep, -infinity to -1. And then you just put a union and you would say where?
5 to infinity.
All right. So be careful. Some students will mix x's and y's. So some of them, their i's will go down like that and they'll give -infinity because that's the y's, but you just give the x's, okay? So again, when I do this, so you guys are gonna move on to this, I would highlight my x's, kind of like how I did on that axis, and then I would put them that way, okay? Does everybody see why there's 2 decreasing and 1 increasing on this one? Okay? Again, why am I using parentheses at -1 and 5? Because it's a changeover point. It's technically not increasing or decreasing. Okay, so see if you can do example 2, increasing, decreasing interval. And then we'll do one more. I'll go back to that side and do another. Okay, so let's try this one. All right, who would like to give the increasing interval? Allison, okay, give us your increasing intervals. All right, -infinity to -2. All right, then I'll put a union symbol, then 0 to +2. Does everybody see that? So she's using the x's, which is correct, and the x here is 0. And that's infinity, and that's -infinity. So you technically have 4 intervals that you gotta deal with. So that's exactly right. -infinity to -2, and then 0 to 2. All right? Everybody okay with that? Questions? All right. What about decreasing? Who can give that one? All right, go ahead.
decreasing is -2 to 0, and then 2 to infinity.
All right, so what do these Y's stand for right here, the 4s? So what does that tell us? Yeah, I mean, it's just, you don't use it for increasing and decreasing. It's actually just telling us if you wanted, think about it, if you wanted to do domain and range, right? We can see the domain is what? So if we had to do domain, what is the domain for this graph? All real, everything's used, right? But this would be helpful if you needed to do range, because we can see if we had to do range, remember range are all the what values? Y. So it goes down forever, but it stops at 4. So that might be helpful for us to do range. So what would range be? Remember, go in increasing order, don't go this way. So way down here is what? And then we'd go up to what number? 4. Now I would use a bracket there because we include that. So I want to make sure we can still do domain and range by looking at the picture. What would the domain and range for example 1 be?
All real numbers for both.
All real numbers for both. It goes forever left and right, and it goes forever up and down. So every coordinate is used, okay? All right, one more problem. So if they give you the equation, and you say, well, you know, maybe it's something like this, 5x minus 4, or, you know, it's an x cubed or something like that. And then they ask you increasing or decreasing, might be good to look at the graph real quick. Now, a couple things. You can go into Y1 and plot it, okay? But I wanted to show you something about both of these graphs that they each have in common. So you could go into Y1 and Y2 and just hit graph. So you could type these in on your calculator. So what is this graph gonna look like? 5x minus 4. Yeah, it's a line, positive slope, y-intercept is 4, so something like this. It's not a perfect graph. But there's that picture. So you can graph these if you just go into your y equals on your calculator and then you hit graph, you can get a picture, okay? What does x cubed look like? Do you know that graph? X cubed, what does that one look like? It's just a squiggle with no hill or valley. It's just kind of like a real quick squiggle like that. So again, you can look at these pictures, but these two have something in common. So on just each one, do the increasing, do decreasing for each problem, okay? Increasing and decreasing for each one. I picked this because they both have something similar, okay? What do you not see? Yeah, there's no hilltops or valleys, so it doesn't change. So this graph, a line, if it's got a positive slope, is always increasing. So you would say where to where? Yeah, negative infinity to infinity. It's increasing everywhere. So what do you put for decreasing if it's not? I always put, if an answer does not exist, we put D and E. Okay? We put D and E. So what do you see with the x cubed graph? Is it ever decreasing? No. So it's the same answer. These are the same. These are the answers for both pictures. Okay. All right. Any questions about increasing or decreasing? Do you feel you can get those by looking at the pictures there and doing that? Okay. All right. Last thing, average rate of change. I'm going to kind of show you what's the reason for that and how we use it, and then we will that'll conclude this lesson. All right, so let's do average rate. Can I erase the board? You guys have just about everything. All right, I'll start erasing over here. So we'll use this space here to do it. This will be, I think, example 3. So what we got. I think this is better if I make it more of an application problem. There's a formula used for average rate of change, but an application problem is gonna help us a little bit here. So I'm gonna give you the graph, but the graph is gonna have meaning. So this is the graph of 40x squared. And we're gonna plot the point 0, 0, and we're gonna plot another point at time is 2. And I'll explain what this time is. So the time, the horizontal axis is time in hours. So that's what X stands for. X stands for time in hours. And the vertical axis, Y, stands for miles driven. And this point up here is at 160. Okay. All right, so this represents, so you're just driving in a car. This represents, the graph represents the distance traveled over a 2-hour time period. And this is tells how far the car has traveled. So at 1 hour, the car is traveled this far, whatever this Y is, which we could get by plugging it into the equation. Okay. So the fancy words, average rate of change. Does anybody could give this a different meaning? What is it asking for? It is asking for the slope. Yeah, I got to give you 2 points. Okay, but what does it mean though in terms of this problem? It's saying give us the average. So we're going to do average rate of change. We're going to say x1 is 0 and x2 is 2. So we're going to do the average rate of change from 0 to 2. But what does it stand for? Yep.
Like how fast the car's accelerating? No? Okay, cool.
No, it's not that. I mean, that's not what it's asking. I'm trying to think, like acceleration is going to be hard to gauge. Okay, so the question is, what does rate of change stand for? It doesn't stand for acceleration. You're going too far, yeah?
How far the car is going in like times 2 hours? Like how the car, the rate of change of, not necessarily how fast it is, but how far it is? The distance?
Speed.
The distance, yeah.
Speed.
Okay.
Rate of change is telling you the average speed or average velocity.
Miles per hour.
That's what this is going to be, because this is miles and this is hours.
Yeah.
So rate of change is a fancy word for giving us the average speed of the car. Because look, here's the thing. I can't tell its actual speed along this route, but I can tell how far it's gone. So for instance, right here at this instant, whatever this is, like somewhere in the first 60 minutes, I can't tell you how fast it's going, but I can tell you how far it's gone, because it doesn't have the same speed. Had this car always had the same speed, it would just be a linear function. I do know this, after 1 hour, it's traveled how far? How much? Yeah, how'd you get 40? Plug in. It's gone 40 miles. So, is it moving very fast over the first hour?
No.
No. So over a 2-hour trip, the car's speed may change, but there's still an average speed. On average, it's traveling this fast, and that's what we're going to calculate. So to do average rate of change, and a lot of times you'll see this abbreviated AROC, A-R-O-C, so that's what it is. You want the change in the position, which in this case is going to be our y's, over change in time, which is our x's. And Maria said slope, and she's exactly right. That's all average rate of change is. Okay? So what we're going to do is we're going to find the second y and subtract from it the first y. And we know the second x, and we're going to subtract from it the first x. So how do we get the y's that go with these x's? We got to plug into this equation and get the y's. Okay? And then you always do the second y minus the first y, second x minus the first x, And that should tell us the average speed of the car. Okay, so go ahead and do that. So you know your x's. It should be what in the denominator? What should I write? 2 minus 0, that's right. You then gonna plug those in up there to get your y's that go with each one. So when you plug your, I would do x2 first, plug it in to get my y2. Okay, you should be able to get these without a calculator, but. So square your x, then multiply it by 40. All right, so what do you get when you plug in a 2 for x? What's 4 times 4?
160.
Yeah, just don't let the 40 bother you. You plug in a 2, you get 4. 4 times 40 is 160. All right, what happens when you plug in a 0? You get 0. Okay, so we get 160 over 2, which is what? 80 miles per hour. So the average speed of this vehicle is 80 miles per hour. Okay, that means this. It is the slope of this line right here. So just to get an understanding of what we're calculating. Had I connected the 2 points like this, if the car was doing this, this was the path. If that orange was the path of the car, what would that tell you about the car? So my first question is this: at time 0, it's gone nowhere. After 2 hours, it's gone 160 miles. So whether I go along the orange path or the black path, my first question would be this: is the average speed for both of these the same? Yeah, it is. Because look, if you're going to work it again, how do you do average speed? Change in position over change in time. What's this first position? 0, 0. What's this second position? 2, 160. So I go to do average rate of change. Change in y's over change in x's. Guess what answer I get? The same. So what would that orange path stand for? If the car did that, if this was what the car did, what do you think that means? It's on cruise control. This means it's always going 80 miles an hour for 2 hours. This means here, what did the car do? Did it start off fast or slow? Slow. Then what's it starting to do?
Yeah.
It's starting to speed up. Okay? But it doesn't matter. It took both cars the same amount of time to go the same distance. And so that's what average speed is. You don't know the actual speed at different moments, but you do know that. And it's what Maria said, you're just finding the slope between 2 points on the curve. So what do you need in order to do that? You need to know what's your first x and what's your last x, and you plug those in, okay? Question? No? Okay. So we'll try another one here. All right, we'll call this last one example 4. So let's just say your y equals negative 2x cubed, and we're going to find the average, I'm just going to put AROC, average rate of change from x1 is negative 1 to x2 equals 2. All right? Don't worry about this like being a car problem. Just do the formula that we talked about and see if you can get the answer. So you don't need to draw a picture, you just need to know how to make those computations. That's it. Okay, what's the formula for average rate of change? What do I do? Yeah, you just do slope. So if you want average rate of change, you're gonna do y2 minus y1 over x2 minus x1. All right, now, you already have your x's. Okay, so you know on the bottom, it's gonna be 2 minus -1. Okay, so the denominator, your denominator should be what? Should get 3 for your denominator. Now, to get my y's, I gotta plug in. I notice it's a -2 in front. So to get y2, it's gonna be -2 times 2 cubed, minus to get y1, it's gonna be -2 times -1 cubed. So let's see, your y2 looks like to me is -16, okay? All right, and it looks like over here, your y1 is 2, okay? So when you plug in, what is our answer? So we should get our average rate of change is -16 minus 2 over 3. -18 over 3 is -6, and that should be your answer. Okay? That's how you do average rate of change. Okay. Questions? So for finding slope, you have to find the y's that go with each x. Okay. All right, and that's it for 1.4.